Hi everyone, welcome to the second of our third lecture example on the topic of complex numbers, de Moivre and Euler formulations. So we're going to begin with this first question, the second question. There's only one question in this video, so the question reads, show that cosh squared x minus sin squared x is equal to 1. Now this cosh, C-O-S-H, that's the hyperbolic cosine, and that's pronounced cosh. And similarly, we've got sin H, that's the hyperbolic sine, so that's pronounced shine, like sunshine. So these are hyperbolic trig functions, this is what they're called. And we also have tanh, so that's tan hyperbolic. So this question is formulated in the way such that it's a show that question. So that means you need to start at one side of the equation and your final answer should be the other side of the equation. So what you need to do before you embark on this question is decide, are you going to start at the left-hand side or are you going to start with the right-hand side? Now in this question, it makes sense to start with the left-hand side because you can't really do much with a 1. So we're going to start with the left-hand side. So first of all, we're going to discuss what method are we going to use to do this. So what we're going to do to solve this question is we're going to use a method of factorisation called the difference of two squares. Now this should be familiar to you if you've studied National 5 mathematics. So the difference of two squares basically says if you've got two numbers squared and you're subtracting them, then you can rewrite that as the square root of the number, take away the square root of the other number, multiplied by the square root of the number plus the square root of the other number. So the example we've got on the screen is a squared minus b squared. That's equal to a minus b, a plus b. And this is because the square root of a squared is just a, and the square root of b squared is just b. So following that logic, the square root of cosh squared is going to be cosh, and the square root of shine squared is just going to be shine. So using that formula in the box, I get that cosh squared x minus sin squared x is equal to cosh x minus sin x multiplied by cosh x plus sin x. So where do we go from there? Because that does not look anything like the number 1. So what do we do now? Well, what we do is we rewrite our hyperbolic trig functions in terms of their exponential form. So the cosh of x is equal to e to the x plus e to the minus x over 2. And sin of x is equal to e to x minus e to the minus x over 2. So all I've done here is I've just lumped these together under the one fraction, and we're going to tidy these up in the hope that it simplifies to be 1. So the next thing I'm going to do is I'm going to get rid of my brackets and burst them out. Just be careful of my minus signs here. I'm going to have a minus times a minus in the first fraction, so just be mindful of that. So I've burst my brackets, that's the second line on this slide. And then what I recognise now is things cancel out. Now the things that cancel out are highlighted in blue font. So I've got an e to the x in blue and a minus e to the x in blue on the first fraction. And in the second fraction I've got an e to the minus x, take away e to the minus x. So these things cancel out. So you could just put a line through those and you're working. Now what I'm going to do now is I'm going to rewrite that line, removing the blue things. Okay, so that's the next line, so that's the very top one. And then what I do now is I recognise that I've got an e to the minus x plus e to the minus x. So that's 2 e to the minus x. And then similarly in the second fraction I've got e to the x plus e to the x. So that's 2 e to the x. Now what I can do now is I can simplify this fraction. So you've got a 2 top and bottom, so I've highlighted those in blue because we can cancel those out. So just put your pencil through those 2 2's on each fraction, and then we are left with e to the minus x times e to the x. Now what we need to do now to simplify this is we need to consult one of our rules of exponentials. So the rule of exponential, it says that e to the a multiplied by e to the b is equal to e to the a plus b. So what I've done here is I've just rewritten that. So I've got e to the minus x times e to the x. that's equal to e to the minus x plus x, and that's equal to 0. So we've got e to the 0 now. Now, e to the 0 is one of our special values that we need to know. But if you forget, remember, you've got a calculator, so make use of it. So e to the 0 is equal to 1, and that's equal to the right-hand side. And that's us finish this example, show that example. And then in the next video, we've got our final lecture example. So once you've watched the final lecture example for question 3, that's all the material for the course all covered. Okay, thanks for watching. Bye.